Spotify has 100 million songs, and somehow it still finds your song in less time than it takes you to blink. How? The algorithm behind it is so simple you could draw it on a napkin. I'm going to show you that algorithm. Then I'm going to show you why it completely falls apart at Spotify's scale. And then, how they fixed it with a trick that's borderline cheating. Stay with me, because once you see this, you'll start noticing it everywhere. It's called Nearest Neighbors, KNN, and it's the foundation underneath almost every recommendation system you use. Spotify, Netflix, TikTok, Pinterest, every dating app on your phone. Once you see it, you can't unsee it. Here's how it works. Okay, if I picture a scatter plot, red dots are cats, blue dots are dogs. Now a new gray dot shows up somewhere in the middle, and we have no idea what it is. So what does KNN do? It looks around, finds the 3 nearest dots, 2 red, 1 blue. Majority wins. It's a cat. That's it. That's the whole algorithm. The K is just how many neighbors you check. K equals 3, you check 3. K equals 5, you check 5. They vote. Majority wins. No training, no equations, no optimization. KNN is what's called a lazy learner. It doesn't actually learn anything. It just remembers everything. The model is the data. So when a new dot shows up, it checks every single point it has, finds the closest ones, takes a vote. That's it. On the wild part, this actually works. Because in the real world, similar things cluster together. Songs you love have the same tempo, the same energy, the same mood as other songs you love. People who like the same 5 albums probably like the same 6th one. So, what are you near turns out to be a surprisingly good answer to what are you? Okay, so if it's this simple and it actually works, why doesn't Spotify just run KNN? Because at their scale, it doesn't just slow down. It breaks in 3 different ways. Every prediction in KNN means measuring distance to every training point. 1,000 songs, 1,000 calculations. Fast, 1,000,000 songs, 1,000,000 calculations. Slower, 100 million distance calculations every time you press play. For every one of their 500 million users, simultaneously. The math doesn't work. The servers would melt. Your phone would heat up before the song even started. KNN doesn't actually learn anything. It just memorizes, which means the model is the data. No compression, no summary. 100 million songs means 100 million items sitting in memory, forever. You'd need a data center the size of a city block just to store the model. Speed is a problem. Memory is a problem. But this third one, this is where the math itself starts breaking. A song isn't just one number, it's hundreds. Tempo, energy, mood, danceability, genre signals. Every song becomes a point in a space with hundreds of dimensions. In 2 dimensions, distance feels normal. Some points are close, others are far away. But keep adding dimensions, and something strange happens. Everything starts spreading out. Your nearest neighbor stops feeling near. Points that looked different distances apart start looking almost equally far away. This is called the Curse of Dimensionality. Why it happens is a story for another video. But the result is simple. Finding good neighbors becomes surprisingly difficult. Spotify ran into all 3 problems: speed, memory, dimensions. And one engineer at Spotify kept hitting the same wall over and over again. His name was Eric Bernardson. KNN was too slow at Spotify's scale. Checking every song against every other song was impossible. So he changed the question. Instead of asking, what is the exact nearest neighbor, he asked, what is a neighbor that's probably close enough? That tiny shift changed everything, because now you don't have to search the entire space. You can narrow it down first. Here's the idea. Take all your songs and split them into groups, then split those groups again and again. You build a giant tree of smaller neighborhoods. Now when a new song shows up, the system doesn't check all 100 million songs. It follows the tree. At each step it asks, which side is this song on? Left, right, left again, until it lands in a small nearby group. Then it checks only those songs. But it's not always perfect. The search finds the closest song in its group and stops. The real closest might be one boundary away. In a group it never opens. One line away, and completely invisible. One tree got unlucky. Its boundary fell right between you and the nearest song. So Spotify builds hundreds, each slicing the music differently. In some of them, that song lands right next to the ones you love. Ask them all, and the song most trees agree on wins. Still, it's fast enough to feel instant. This algorithm is called Annoy. Approximate Nearest Neighbors. Oh, yeah. That is genuinely what it stands for. And it became one of the systems behind modern music recommendation. All because of one simple idea. Maybe you don't need the perfect answer. Maybe you just need a good one. And Annoy is open source. Spotify put it out there for anyone, so we could build the whole thing ourselves from scratch. If that's something you want to see, comment Annoy. If enough of you do, I'll build it.